I'm going to be solving a third example, and I'm going to be solving for two trigonometric ratios, sine theta, cosine theta, in the following equation. Since there's two trigonometric ratios, and I'm going to be solving through substitution, I'm going to be defining two new variables. So I'm going to say let A equal to sine theta and B equal to cosine theta. So substituting those new variables in for sine and cosine, I have a times b plus 2a is equal to 0. I factor out, I notice that in this equation on the left-hand side, I have a common factor of a. So I factor out a. I'm left with a times b plus 2 is equal to 0. And then I use the zero product property to equate that both factors are equal to 0. I solve for a and b, so I get a is equal to 0, b is equal to -2. Don't forget what we're originally trying to solve for sine and cosine. So I substitute back a is equal to sine, b is equal to cosine, and I have the result of sine theta is equal to 0, cosine theta is equal to -2. So directly solving, I'm going to solve for trig ratios, sine theta and cosine theta. I'm probably able to see, if I look carefully, does there exist a common factor in both terms on the left-hand side? Sine theta. I'm going to factor out sine theta. So what I get is sine theta times cos theta plus 2 is equal to 0. Make sure that you multiply through to double check that you get the same result above. So I use the zero product property. Sine theta is equal to 0. Cosine theta plus 2 is equal to 0. Solve for each factor. Sine theta is equal to 2. Cosine theta is equal to -2. This way is so much shorter. However, it is far trickier and requires practice. Let's look at the most challenging example of them all. Example 4. So we're going to solve for sine theta. So take a look at this equation. It may remind us of last unit's quadratics. So I'm going to try to factor this. What? I can't factor that. I've tried it. Maybe you want to try. This is deceiving because it looks factorable. One strategy I may want to employ is substitution. So I let x equal sine theta. That results into the trigonometric equation to being x squared plus 2x minus 1 is equal to 0. This is not a factorable equation. When something's not factorable, what do we do? Use the quadratic formula, I'm hoping you'd say. So I've just let a is equal to 1, b is equal to 2, c is equal to -1. In other words, the coefficients of x squared, x, and the constant term. I use the quadratic formula to solve for x, plug in my values, and I should end up with the result that x is equal to -2 plus or minus the root of 8 divided by 2, which can be simplified that x is equal to -1 plus or minus root 2. Remember what you were solving for originally. We're solving for sine theta. So sine theta is equal to -1 plus or minus root 2. Now this is a difficult question. However, it will be more difficult and the question will continue